energy of the tide is phenomenal. It can roll inland for tens of kilometres, tearing apart the riverbank along the way.
We normally think of rivers flowing out to the sea, but the power, the tidal surge here, means that it goes upstream. I mean, this channel is about 400 metres wide, but the force of the tide makes the river run backwards. Woo! Look at that!
This tidal bore shows just how much energy is created by the moon and the sun's gravity and released in a tide.
That wave is probably going to travel for 25 kilometres. And it's going to move about 400,000 cubic metres of water every minute. That's 4 times the flow of the Niagara Falls.
The oceans capture, store and deliver energy, whether it comes from the wind or the gravitational pull of the moon and the sun. The energy is turned into a powerful force that has carved the coastline of every continent. This is a battle for territory between land and sea that's been fought for billions of years. On the northwest coast of America is one of the most dramatic coastlines created by this age-old conflict. But 12 million years ago, this coastline would have looked very different. Even though the cliffs are made from basalt, a particularly tough rock, over the years the sea has attacked every line of weakness. Today, only the hardest outcrops are left behind. They're called sea stacks. But even they will eventually be ground away. Closer to home on the east coast of England, where the sea is faced with a less formidable opponent, the whole process happens terrifyingly quickly. Here, the cliffs are just loose soil. This is what the sea destroyed in just 3 years. Over the last 500 years, the coast has retreated more than a kilometre. But destroying coastlines is only the most evident demonstration of the sea's great power. The oceans influence our planet in many far more subtle and profound ways. They drive the climate. They deliver oxygen to our atmosphere. And below the ocean surface is an extraordinary network of currents that are critical to the well-being of all life on Earth. But 4.5 billion years ago, when our planet was born, it was just a molten inferno. There was no place for any water at all. Yet the ingredients needed to create water were there, locked away deep inside the Earth when the planet formed. As the first volcanoes erupted, one of the gases that billowed out was steam. And as the planet cooled, it formed clouds. So began the longest rainstorm of all time. It rained for thousands of years. As the first rivers formed, they began to fill up the low-lying areas on our young planet, creating the first oceans. But it's reckoned that even this relentless downpour only delivered around half the water that makes up our oceans today. The rest came from outer space. This is a comet, filmed in 2005. It's about 6 kilometers across, and like all comets, it's made of rock and water in the form of ice. To discover just how much water comets contain, scientists deliberately crashed a satellite straight into it. As it ploughed into the surface, more than 250 million litres of water burst out into space. In Earth's formative years, it was hit by thousands of comets like this. By the time the bombardment finished, it's thought they'd delivered up to half the water in our oceans. Together, volcanoes and comets gave Earth all the water the planet will ever have. The amount of water in the oceans has stayed roughly the same ever since they were formed about 4 billion years ago. But the oceans themselves are continually changing. As the continents move over millions of years, new oceans open up, whilst others vanish. It's hard for us to grasp because it happens over such an immense timescale. Yet today in East Africa, we can actually see the beginnings of a new ocean. This long, deep fissure in an area of Ethiopia called the Afar Depression is where the planet's next ocean will form. It appeared in 2005, when the land was suddenly ripped open by a massive earthquake. Nearby, similar tears and fractures scar the desert for hundreds of kilometers. This is a continent splitting apart. It may take a few million years, but eventually these cracks will spread, and 3 giant slabs of the Earth's crust will start to separate. In time, a single crack in the desert will have turned into a new ocean. But something as enormous as an ocean cannot simply come and go without having profound repercussions. Take the Mediterranean. This sea has remained a constant throughout human history. Great civilizations have risen and fallen along its shores. Below me is a strip of water that's been fought over for the past 3,000 years. The Romans, the Moors, the Spanish and the British have all battled to control this narrow passage. Because if you rule the waves down there, you control the only gateway between the Mediterranean Sea and the vast Atlantic Ocean. You control the Straits of Gibraltar. But that's just our short-term human perspective. In terms of Earth's long history, the Straits of Gibraltar have played a very different role, because the Mediterranean is barely clinging to life. This sea, like all seas, is constantly evaporating. The problem is the glare of the sun causes the Mediterranean to lose 3 times more water through evaporation than it receives from rivers and rain.